Welcome to lecture number 3. So in the previous lecture, lecture number 2, I provided a definition of statistics, and I said that we were going to focus on data and that there are multiple ways to classify variables and the data that we get from these variables. So this lecture will focus on the types of variables and data that we can use, the fact that not all variables and data are equal. We can do or not do certain things depending on the type of data that we have. So in this lecture, we'll cover a definition of variables and data. We will explain how data can be classified as qualitative or quantitative. How data can be classified using the scales of measurement, nominal, ordinal, interval, and ratio. And finally, the difference between continuous and discrete. And if it's continuous, I will briefly discuss the function of real limits. So in the previous lecture, I gave you a definition of variables and data. And so I said a variable is simply anything that can take on more than one value. It can be your height, it can be your weight, your gender, your sex, etc. And the measured values that we get from a variable, that's what we call our data. And again, it sounds unusual. It sounds like I should say data is, but it's data is plural. So data are simply the measurements or observations that we get from a variable. Usually numerically, but it doesn't have to be numerical data. For this class, sometimes we'll look at categorical, nominal, ordinal, etc. So the point of this video is not all data are the same. They have different categories, different abilities, different things we can do provided with using arithmetic, some things we can and cannot do depending on the type of data that we have. And so the goal of this lecture is literally to show you how data in variables can be classified using multiple dimensions. So here's a little hierarchy, although it's misleading because it's not necessarily an appropriate hierarchy. There's no reason to say that discrete couldn't go up here and so forth. It's just an organizational chart, and you won't always find it arranged this way. I just created this because it makes sense to me. So the first way we will differentiate data is qualitative versus quantitative data. And qualitative can be called categorical. You can use them interchangeably. It doesn't matter. Qualitative or categorical. And the key thing with qualitative is quality. There's not an amount that makes it, it's a quality that makes it. So here we have hair color, we have gender, sex, race, your favorite movie type, whether it's romantic comedy, whether it's action, fantasy, doesn't matter. So qualitative or categorical. Sometimes we use numbers over here, but the numbers don't actually mean an amount of anything. So we could say 1 for male and 2 for female. Well, that 1 and 2, they don't denote an amount of anything. They're just allowing you to say, well, here's how we've classified. 1 is a male, 2 is a female. I could have easily said 1 is female, 2 is male. So even though numbers can be used, the numbers in and of themselves don't convey an amount of something. So it's not truly numerical data. Quantitative data, there's a quantity. That number means something. So it's sometimes called numerical data. This could be your height, your weight, your income, the number of classes you're taking, etc. If your data are qualitative or categorical in nature, they can be classified using one of the 4 scales of measurement, or technically only 2, since it's qualitative or categorical. The other 2 scales of measurement would be under the quantitative or numerical. So nominal, ordinal, interval, and ratio, these are the 4 scales of measurement. If you have qualitative or categorical data, your only choices are nominal or ordinal. And nominal data does just one thing, it names. You may still have a number, like a football jersey number, but player 20 isn't bigger or faster or stronger than player 19. It could be player A versus player B. So the numbers don't really mean an amount of anything. With ordinal data, we have some order in addition to all the abilities we had with nominal data. And so this could be first, second, third place in a race. It could be letter grades. A is better than a B, B is better than a C. We can put them into some meaningful order. If we have quantitative or numerical data, we can classify it as interval or ratio. And again, these are the 4 scales of measurement. With interval, we still have the abilities of nominal and ordinal. We just gain one additional ability. So nominal just names, ordinal names and ranks. With interval, we have equal consistent intervals. For example, the difference between an A and a B letter grade, that's ordinal data, the distance between an A and a B is not always the same. If you had 100, you would have an A. If you had a 79.5, that would be a B. In that case, you have over 20 points separating the A and the B. If you have a 90 and somebody else has an 89.4, then the difference between an A and a B was just a little over 1 point. And so the distance between an A and a B, or a sophomore and a freshman, is not always the same. But if you have interval data, there's always equal intervals. The distance between 71 degrees and 72 degrees is always the same. It's always consistent. And the distance between 72 and 73 was the same as 71 and 72. So we have equal intervals. What we don't have is a true meaningful zero. And if we don't have a true meaningful zero, we can't make a ratio statement, such as twice as much or half as much. So if we have interval data, such as temperature, with the exception of Kelvin, it's actually inappropriate to say 70 degrees is twice as hot as 35 degrees. Because when we say it's 0 degrees outside, whether it's Celsius or Fahrenheit, that doesn't mean it's as cold as it can get. It just happens to be, it's not technically arbitrary, but that 0 doesn't mean 0. But if you have ratio data, then you have a true meaningful zero, and it does make sense to say 10 pounds is twice as much as 5 pounds. It does make sense to say that 5 miles is half as much, half the distance as 10 miles. Now, if we have interval data or ratio data, in other words, we have numerical or quantitative data, and so that's why I said this is not necessarily a strict hierarchy. We can have either discrete or continuous interval data, and we can have either discrete or continuous ratio data. And discrete data is typically counted data. There are exceptions that don't quite fit, but you can think of discrete as being counted, whereas continuous is being measured. And it can be either ratio or interval. Discrete is always exact. So you could say I've got exactly 3 cats. I don't have approximately 3 cats, but I weigh approximately 230 pounds. I don't weigh exactly 230. So with continuous data, there's always the possibility of an infinite number of possibilities between any 2 points. So it's approximate, but I'll add some detail to that in just a minute. So let's take a look at the difference between qualitative and quantitative. And again, you can call qualitative categorical and quantitative numerical. You can use them interchangeably. And qualitative or categorical has to be either nominal or ordinal in terms of the scales of measurement. And quantitative has to be interval or ratio. And these are just examples that I mentioned just a few moments ago. With the scales of measurement, again, we have the nominal, ordinal, interval, and ratio. And with each step we gain, we never lose an ability. So nominal does one thing and one thing only. It names something as unique. It names. So example of nominal data, jerseys, jersey numbers. Again, player 10 is different than player 5, but not necessarily better or worse. Your phone number, you can't say my phone number has more than yours, because even though there's numbers, the numbers could be replaced with letters, and it's just designed to say my number is distinct, is different from yours. Social security numbers, your race, gender, sex, political preference, these are just nominal classifications. With ordinal, we gain an additional piece of information. We can take our category and now we can put it in order. So I can't say that libertarian is better than a conservative and a conservative is better than a liberal. I could say that, but it's just opinion. There's not an amount of something that makes one better or worse than the other. But if you have ordinal data, you can put these categories in a specific, meaningful order. I know first place did better than second place. I don't know how much better, but I know this person did better. And second did better than third. I know A on a test is better than a B, and B is better than a C, and C is better than a D. I know a sophomore has more hours than a freshman. I know a junior has more than a sophomore. I know a senior has more than a junior. So I can put these in some meaningful order. With interval data, again, I still keep the abilities of ordinal, but I gain an additional piece of information, and that is equal consistent intervals. So with ordinal, I could have a, let's say a junior with 89 hours, and I could have a senior with 90 hours. So the difference between a junior and a senior in one case could be 1 hour. Or you could be a junior with 60 hours, and you could be a senior with 120 hours, in which case we have a 60-hour difference. So the classification, sophomore, junior, senior, etc., the difference between each one doesn't remain consistent, doesn't have to be. But if you have interval data, which is typically going to be temperature, with the exception of Kelvin, which is ratio, but Celsius or Fahrenheit, most standardized test scores, IQ, ACT, GRE, etc., they are interval. They don't have true zero, so you can't make a zero IQ. You can't make a zero on the ACT. You can't make a zero on the GRE. So it's tempting to say, maybe I scored a 30 and you scored a 15 on the ACT to say I did twice as well as you did, or you did half as well as I did. But you can't, because there's no such thing as a zero on the ACT. So at best we have interval. But with ratio, you can make that ratio statement half as much, twice as much. And the reason you can make that is because you have a true meaningful zero. So if I tell you it's 30 degrees outside and it's going to drop down to 0 tonight, can it get colder than 0? It can. It can get much colder. So when we say 0 degrees Celsius or Fahrenheit, we're just saying it's cold, but it's not a lack of energy or movement in the molecules like 0 degrees Kelvin. But if I tell you I have 0 horses or ponies in my house, then that 0 is true. It's meaningful. It means it's an absence of something. And if I am 6 feet tall and you are 3 feet tall, a child, then you could say 6 feet is twice as tall as 3 feet. Right? So these are the scales of measurement: nominal, ordinal, interval, and ratio. And each time we go up, we get an additional piece of information. We don't lose it. Finally, a third way to classify our data is either continuous or discrete. Typically, discrete data is counted. There's probably exceptions. And continuous data is typically measured. So I would count the number of students in my class, but I would measure their weight. I would measure their height. Discrete data is always exact. So I have exactly one wonderful wife. I have exactly 3 cats. I have exactly 1 truck. And I can't get any more precise than that. With continuous data, it's always approximate, because you can always be more precise depending on the measuring device that you're using. So if someone says, hey, I ran the 100 meters in 12 seconds, and they measure that using an old analog watch, better stopwatch could say 12.1 seconds. And a more sophisticated watch might say 12.14 seconds. And so you can always become more precise depending on your measuring device if you have continuous data. So with continuous data, you can take any 2 points What's between 1 pound and 2 pounds? 1.1, 1.01, 1.001, an infinite number of possibilities. But with discrete data, what's in between 1 penny and 2 pennies in a jar? Well, it's either 1 penny in a jar or 2 pennies in a jar. You can't get any more exact. It makes no sense to say there's an infinite number of possibilities between 2 students in a class and 3 students. There's either 2 or 3. And so that's why they're always expressed as integers or whole numbers. You will never see 1.49 and have someone correctly classified as discrete data. If you have continuous data, so remember, continuous data is always approximate. We can always be more precise if we have a more precise measuring device. So for that reason, sometimes real limits, upper and lower boundaries, or upper and lower limits are created. And we're not talking calculus here, we're talking about boundaries. Right? And so the reason we would create these is because continuous data are always approximate data. And so what the purpose of real limits are is to provide us a range of possible scores where your actual score would fall if you gained one level of precision on your measuring device. Right? So if I tell you I was measured to be 72 inches tall, I can't correctly tell you that I'm 72 inches tall exactly, because you could get more precise. If you had a better measuring device, perhaps I'm somewhere between 71.5, this would be the lower limit, and 72.5, not including 72.5. So to find the lower and upper limit, all you have to do is look at the last column. And the last column that's shown is the ones column. So half of 1 is 0.5. So I subtract 1, it gives me 71, add a 5, 71.5. Then I add a 0.5, 72.5. My original value has no places behind the decimal, so my answers must have 1 place. If my original value had 2 places behind the decimal, my answers would have to have 3 places behind the decimal. You have to have an additional level of precision. So most of the time, to find the upper limit, all you have to do is add a 5. So 72, just add a 5. Don't forget there's a decimal there, 72.5. And subtract 1 and add a 5 again. And so if I subtract 1 from 72, I get 71, add a 5. Your answer will always end in a 5. Let's say we have 230.4 pounds, which is about what I weigh today. And so in this case, the most precise column that I have is the 10th column, not the ones column anymore. So 10th column, half a tenth is 0.05. But again, to find the upper, I'm just going to add a 5 to my original value. That's where I got 230.4, and then add a 5. And you'll notice my original value has 1 place behind the decimal. Therefore, my answer, my upper limit, has to have 2 places. Right? Then I subtract 1, so that gives me 230.3, add a 5, and I get my lower limit. And remember, we only do this with continuous data. So I can promise you, somewhere on a test, I'm going to say, find the upper and lower limits for 30 students in a classroom. And you're going to say, that's a trick question, because you can't get any more precise. If I tell you there are 30 students in a class, and that's as precise as you can get. So real limits are only found for continuous data because they're approximate, not discrete data. Discrete data are already exact. Let's do a few practice questions. Time to run a marathon is numerical, true or false? And that is absolutely true. It's also ratio. It's also continuous. Time to run a marathon is interval. We said that's false. We said it is ratio. If someone runs a marathon in 3 hours and it takes me 6 hours, and I doubt I could do it in 6 hours or 12 hours, but 6 hours is twice as long as 3 hours. It's a ratio statement. So this is false. We said it is quantitative. That is correct. It's not qualitative. And so definitely quantitative. Interval and ratio are numerical. That is correct. Whereas nominal and ordinal tend to be categorical. Interval and ratio are numerical. That is true. Political and religious preference are not numerical. Political and religious preference are categorical. And in this case, specifically, they would be nominal. So this is false. Hair color is nominal for the purposes of this class. So when we say color, I'm talking about the subjective experience of color, not the underlying frequency that maybe someone in physics would be interested in. So blonde, brunette, gray, whatever it happens to be, that is nominal. That is true. 80 degrees Fahrenheit is twice as hot as 40 degrees Fahrenheit. That is false, because temperature, with the exception of Kelvin, is only interval. And when we say it's 0 degrees Fahrenheit, that doesn't mean it can't get any colder. So that, again, it's not arbitrary. There's a reason it's set that way, but it doesn't mean the absence of energy or movement in the molecules. If I said 80 degrees Kelvin, that would be true. But 80 degrees Fahrenheit or Celsius centigrade is false. Real limits are only computed for continuous data. That is true, because continuous data are approximate. We don't find real limits upper and lower. Sometimes you'll see them called boundaries for discrete data. Most standardized tests yield interval level data. This is true. I can't tell you how many people I've encountered that they say, well, I've got a IQ of 140. They probably don't, but maybe they do. And that means I'm twice as smart as someone with a 70 IQ. Well, you can't say that, because there's no such thing as a 0 IQ. You can't make a 0 on the ACT. You can't make a 0 on the GRE or LSAT or MCAT. So most standardized tests at best yield interval level data, not ratio. So this is true. Nominal and interval equal categorical. That is false. The reason it's false is because nominal and ordinal would equal categorical. Interval is numerical in nature. Discrete data are typically measured. We know that is false. Discrete data are typically counted. The number of pennies in a jar, the number of students in the classroom, the number of cars in the parking lot, the number of children you have, the number of friends you have, the number of courses you're taking, typically counted rather than measured. Whereas continuous data typically are measured. Continuous data are exact. That is false. We know it's false, but continuous data are always approximate. Discrete data are always exact. So it's tempting to say, hey, I studied an hour last night. And you can't say I studied exactly an hour. You studied approximately an hour, because time is continuous. And so continuous data are approximate. The upper and lower limits for 21 pounds, the first thing you got to ask yourself is, has he given me numerical data? And yes, I have. And is it continuous? In pounds, weight is continuous. And so to find the upper, just add a 5. So 21.5, that looks correct. Subtract a 1, that gives me 20, and then add a 5, and that looks correct. And I've got one place behind the decimal. Started with 0, so I gained that one additional level of precision. This looks true. And that is the end of the presentation. So as always, you can call, text, or email me. You can set up a Zoom meeting. Just let me know. And I hope these questions or PowerPoints help you.